Now in this example, I want to show you the relationship between electric current and number of turns in a solenoid with the magnetic field strength. Assume the magnetic field produced by a solenoid is 6 times 10 to the power of negative 6 Tesla. Part A, if you increase the number of turns per unit length of the solenoid, would the magnetic field strength increase or decrease? Let me write down the formula for relationship between number of turns per length and magnetic field strength. Number of turns per length is going to be lowercase n, and as you see here, this is directly proportional to B. So as you increase number of turns per length, the magnetic field strength increases as well. So the answer to part A is going to be increase. Part B. If the number of turns per unit length of the solenoid is increased by a factor of 4, what would the resulting magnetic field strength be? So it becomes 4 times, so it means that B becomes 4 times bigger. So it's going to be 4 times 6 times 10 to the power of negative 6. We don't need to use the calculator. 6 times 4 is 24. 24 times 10 to the power of negative 6 will be 2.4 times 10 to the power of negative 5 Tesla. Part C, if the number of turns per unit length of the solenoid is decreased by a factor of 2, it means that it becomes half, what would the resulting magnetic field strength be? So B will be half of 6 times 10 to the power of negative 6. So we divide it by 2 is going to be 3 times 10 to the power of negative 6 Tesla. That's how we find out the relationship between number of turns per unit length of a solenoid and the magnetic field strength.